Hi everyone, and how are you doing today? I'm just going to make a very short video just to quickly review the contents of chapter 1. I'm going to do a similar review of chapter 2, then chapter 3. So just do this in sort of quick and dirty bite-sized chunks because you do have the video lectures, but this is just to help you get some kind of a reinforcement of the basic concepts. So in chapter 1, really in our text, just deals with basic data and data types, and understanding the sort of measurement skills that are associated with different types of data. So we're going to go through that. And then in chapter 2, we'll talk about how you organize that data once you have it so that we can begin to create a picture from the data that we actually have, okay? So this course is about the study of statistics, and the question you may want to ask is, what is statistics? Statistics really is just about the study of data that is sampled from what we call a population. So it's a set of facts, actual data, and then we take that information, or that data, sorry, and we transform it into information that could help us make better decisions. So there is a bit of art in it and there's a bit of science. Why the art side? Is because one has to design experiments, and in designing experiments sometimes you have to be creative, so there's a bit of art in it, but at the same time there's science that governs the sort of relationships between the data, the variables, the collection methods, and all that sort of stuff. And not only that, once we collect that data, then we have to interpret it and be able to share that data with whomever is going to use it in some form of application. Data, as we've already said, is basically just the facts and figures that we collect, all right? And then we want to be able to interpret that to make some sense. So data typically occurs in what we call a data set. And so, for example, if I have 20 students in my class and I ask them information on a number of variables, then the collection of all of that data that I collected, or the collection of all that data, sorry, is called a data set. So I could ask them their age, their height, color of their eyes, favorite color, favorite food, etc. All of that information would be part of a data set. And then I would have these 20 students providing me that data. So we call the elements the entities on which we collect data. So that each student would represent one element. So our data set in that context would just be 20, would have 20 elements in it. All right? The variables is the characteristic that we collect data on. So for example, height, age, gender, these are 3 different variables that I just counted off for you. And we are basically going to determine which variables are of interest to us and then collect that sort of data whenever we're putting a data set together, all right? And then each piece of information you collect on a variable is called an observation. So if there are 20 students, and one student gave me their height as 6 feet 1 inches, that's an observation out of the 20 elements in my data set. Now, when we take each variable and we collect the data on, or the facts on each variable, what happens is that we have to be able to measure the data that we're collecting. And so therefore we have what we call different measurement scales. There are 4 basic measurement scales. And one is called nominal. So the other 3 are ordinal, interval, and ratio. So nominal, ordinal, interval, and ratio. And so basically they will help us determine the amount of data that we've actually collected on a given variable. So what are nominal types of data? Nominal basically says that the data occurs in different categories. There's no ordering, there's no preference, there's no hierarchy. So if we simply gather the color of shirt that each person in the data set is wearing, then that's an example of having nominal data, all right? There's no hierarchy. Red is not better than blue, blue is not better than green, green is not better than orange, etc. Ordinal data is when you have this sort of categorical data, but it has an order to it. So if we, for example, look at grades, when we talk about A, B, C, D, and then F, then in that case, an A is better than a B is better than a C is better than a D, and a D is better than an F. So therefore, there is an order to it. There's a natural order, and so we refer to that as ordinal. And it should be very easy to be able to determine that because it has the word ord in it, O-R-D, which is connected to order. Interval data, on the other hand, is data that it's typically numerical data, and there are sort of these fixed intervals between any two data points. So for example, temperature between 20 degrees and 30 degrees, there are a set of there are sort of intervals, and each interval is of the same size. So if we measure and 1 degree at a time, we go from 20 to 21, 21 to 22, and each of those will be of the same size. In interval data, however, there is not an absolute zero. Zero tends to be a reference point. So for example, temperature. Zero temperature does not mean that, or 0 degrees Celsius does not mean that there is an absence of temperature. It's just a reference point. And that reference point in the context of Celsius is that water freezes at 0 degrees Celsius. All right? And so, and 0 degrees Fahrenheit, clearly the water is already frozen by then, because we know that 32 degrees Fahrenheit is the same as 0 degrees centigrade. So you could see how these are two different temperature scales. One says 0, water is freezing. The other one says 32, water is freezing. Okay? So interval data does not have an absolute zero. And then, of course, finally, we have what we call ratio data. And ratio data is the one that has an absolute zero. And that the ratio of any two values actually makes sense. In the case of interval data, the ratio of the two values may not make sense. So for example, 40 degrees Celsius and 20 degrees Celsius. If you divide 40 by 20 is 2, but it does not mean that 40 degrees is twice as hot as 20 degrees. So in that case, the ratio does not make sense. However, if someone is 4 feet tall and another person is 2 feet tall, then one person is twice as tall as the other, in which case the ratio makes sense. So ratio has all of the attributes of interval data, except that it has an absolute zero. All right? So there is an absolute zero associated with ratio data. Cool. We could also take data and categorize it into two different forms. We could call it quantitative data and qualitative data, or sometimes people use the term categorical and quantitative. But categorical data is basically data that just simply occurs in categories, and they're usually qualitative in nature. So when we say A, B, C, D, E, these are categories of grades. And so, or if we create groups, for example, groups 1, 2, 3, 4, 5, even though the data is numeric, but these are still categories. These are groupings and so forth. And in statistics, when we want to do analysis, of course, there's usually a lot of mathematical transformations that we do, and you could do so easily with quantitative data. You can't do the same thing with qualitative data that easily, unless you do what we call some kind of coding. And this is, at least at this point, beyond the scope of our course. All right? So we see some examples of categorical data as labels and names and so on. And so if we had cities, we could talk about large cities, medium cities, small cities. So these would be different categories. All right? And we've already said that you have quantitative data that indicates how much of something, and it's typically numeric, and that we could do certain mathematical operations with it. We could add it, we could subtract, multiply, divide, and so forth. So that's a good thing to have. So here's a quick summary that we have data. Data can be categorical, or in other words, qualitative. So we could, if we wanted, we could change that and put qualitative, categorical, or quantitative. And quantitative data can be numeric, and be interval or ratio. All right, like height would be ratio data, interval data, such as temperature. Categorical data can be numeric or non-numeric. For example, when we group people into groups like 1, 2, 3, 4, 5, then that is still a category, but is numeric in nature. So having groups 1, 2, 3, 4, 5, these are 5 categories, all right? And then we could have nominal or ordinal data in that context. Or it could be non-numeric, in which case we have things like A, B, C, D, E. And it's ordinal if the data has some kind of hierarchy associated with it, or it is nominal if there's really no particular hierarchy. Now, we also want to talk a little bit about different types of data. Another example is called cross-sectional data. So if I was standing at a particular juncture in time and I spliced across, say, a number of different cities. So let's just say we want to look for rainfall in all the towns in Nova Scotia for on the 25th of January. In that case, then, if we look at the amount of rainfall, all the towns in Nova Scotia, that's called a cross-section. So literally you stand at a given point and then you're splicing across a number of data sets or populations, if you wish. Okay? So that's an example of cross-sectional data. We have also what we call time series data, where the data occurs chronologically. So if we look at weekly sales data, it might look something like this. And so as a time series, we're moving forward in time. And each period is chronologically ordered. So that could be January, February, March, April, May, June, July, right? As an example. So where can we get data from whenever we want to do analyses? It all depends. It depends on what you're studying. And in some cases, if we're looking at a business, we may be interested in production records. We may be interested in employee records. We may be interested in inventory records, sales records, credit records, customer profiles. All of those things are sources of data. Particularly if you want to study consumer behavior, you would need to know your customer profile, and then you may actually want to look at the actual purchases and the types of purchases that they've made. So that gives us quite a bit of information. Some people might even say it's invasive because now you get into people's private lives and looking at what they actually purchase. All right. There are a number of things we could do. Here's a data for 50 tune-ups that occurred at a repair shop, Hudson Auto Repair. If you were given this data, there are a number of things you could do with it. You could find the average of that data. You could find the median. You could find quartiles, percentiles, and so forth. So we're going to learn how to do those for chapter 2. And here we will just basically get a quick sense of what we can potentially do with this data. So one thing we could do is we could do a tabular summary showing the frequency. And if you were to look at the cost of the parts, we could go from the minimum to the maximum and then sort of group the costs into certain categories. So $50 to $59, $60 to $69, $70 to $79, $80 to $89, $90 to $99, and so forth. So that's grouping it into these categories. And then, of course, we could count the number of observations that we have. Now we know what an observation is, which is basically a measurement taken from of a variable taken for one of the elements in the data set. So frequency, in this case, is 2. That means that you have 2 values that lie between 50 and 59, 13 values between 60 and 69, 16 values between 70 and 79, and so forth. So given that we have that, we could convert those values to a percentage. So 2 out of 50 is 4%, 13 out of 50 is 26%, 16 out of 50 is 32%. So that gives us percent frequencies, and those percent frequencies allow us to plot a diagram that looks like this, that we call a histogram. So on the x-axis, we have the groupings, or the categories, and then we have the percent frequencies on the y-axis, the percent frequencies. And those percent frequencies can be useful in looking at where do we have most of our concentration of our data. And as you could see, it's between $70 and $79. So the highest frequency of auto repair parts is somewhere between $70 and $75. So you could tell your clients to pretty much budget for somewhere around $75 when they come to do an auto repair for parts. All right. We could do some analyses with quantitative data, such as the mean, median, and mode. So we'll learn how to do this in the next lecture, and that could be quite useful. Most of us are concerned about average performance on an exam in terms of student performance. So that's an example of a numerical calculation, a non-numerical calculation, but certainly an arithmetic operation that can be done with data that is actually collected. There is this area of statistics which is extremely important, and we're going to get into that from chapter 7, where we talk about statistical inference. And what we mean by statistical inference is that usually we have a population of interest, and then we gather a sample from that population of interest. Then we conduct some analysis with it. And then based on the analysis that we conduct, we could draw now what we call statistical inference. In other words, draw some meaning from the analysis that we've done. What is the data telling us, right? And then that could be quite useful for decision making. We're also aware that it's possible if you have all of the data that is available, then you've conducted a census. Or in some cases, we don't have all of the data, so therefore we will simply do a sample survey. All right, so we have a process for statistical inference, is that we usually have a population. So for example, in the case of tune-ups and parts, so we have population of tune-ups, all possibilities. We take a sample of 50 of them. The sample provides information that the average, for example, is 79 per tune-up. So therefore, we could conclude that it's fairly likely that the average for the entire population is close to 79. It won't necessarily be precisely 79, but it should be close to 79. So that now is what we call inference, taking sample from a population, studying the sample, and then extrapolating the results to the population. And we have a number of things that we do with statistics or data these days. Nowadays you hear a lot about data analytics, and so there are a number of different techniques that we could use when we're doing data analytics. It could be descriptive in nature, which basically says what happened in the past, what is it that we need to learn from. Also, it could be predictive in nature, in that we take the information that we've gathered from past behavior and use it to predict the future. And it could be prescriptive in nature, in the sense that we try to understand from the data what is the best course of action that we should take. So the data should guide our decision making. All right? And we call that prescriptive analytics. So if we could get into those three areas of data analytics, we would be providing quite a service to organizations that have huge amounts of data, but needs to be able to analyze it. And then final thing to keep in mind is that in statistics, just because somebody presents statistics to you does not necessarily mean that the statistics should be believed. There are ethical guidelines, and in some cases, certain researchers violate those ethical guidelines. A number of things can happen, but in some cases, it could just be an oversight. So we have things like improper sampling, inappropriate analysis, maybe using the wrong test, and so on. Development of misleading graphs. So sometimes too much aggregation can hide certain things. Too much disaggregation can end up focusing on the wrong things. So it's good to have a good balance, right? If people extrapolate the results, if for example, say there's just a slight relationship between two variables, but however it's reported that there is a relationship. Now, without saying that it's slight, the reader might get the sense that the relationship could be strong, even though it was not said. So these are some practices that we need to be mindful of and find ways to eradicate those sorts of practices. All right, so that is just a quick summary of chapter 1. I will sort of just review an example for you so that way we can learn from that particular example. All right, that example is going to be problem 25 in chapter 1. So in the meantime, why don't you get that problem, get it ready, and we'll take a look at it in the next video.